Assalamu alaikum dear students, this is Wajid Ali Shah and today we are going to discuss the topic RLC series circuit, chapter number 5 given on page number 181. Dear students, what is an RLC series circuit? RLC series circuit is that one in which the resistance R, inductor L and the capacitor C are connected in series is called RLC series circuit. As we can see in the diagram, RLC, resistance, inductor and capacitance, they are all connected in series with each other and also along with the AC supply. This is what we call RLC series circuit. Dear students, as we know from the previous knowledge that the current and voltage both are in phase while passing through the resistor R. That can be shown in the phasor diagram like this is a phasor vector for V and this is phasor for I, current. Second part of the circuit is inductor. We also know that the voltage leads the current I while passing through the inductor. It is shown in this diagram. These results have already been proved in the previous lectures that the voltage while passing through the inductor leads the current I by 90 angle. This is another diagram for inductor. Third result, individual result is the current leads the voltage by 90 angle while passing through a capacitor. Whenever a current and a voltage passing through a capacitor, so the current leads the voltage by 90 angle while passing through a capacitor. So this is the diagram for capacitor. As it is a series circuit, so current is same along x-axis. In all the diagrams, the current is taken to be the reference vector I, and I. In resistors, voltage is in phase with the current. An inductor, voltage leads the current, and capacitor, voltage lags the current, or we can say that current leads the voltage by 90 angle. Now, what we are going actually to do in this topic here. Now, we are going to calculate the relationship between the voltage, the net voltage, and the current while passing through RLC's series circuit. By using the diagrams above, we can use the diagrams for VR, VL, and VC to find the relationship between V and I. So, we can have the relation as this one, back side of the page. Okay. Dear students, as it is a series circuit, so the current is same and we need to find it, the net voltage, by the use of some mathematical steps or geometrical steps. As we know that the phasor for resistance voltage VR along x-axis from the previous diagrams, VL above it leads the current and VC below it lags the current. So we can have a net voltage by the use of these three phasor vectors. Draw the phasor diagram for VL, VC and VR. VL, VC and VR. Now, actually we are going to find the net voltage of the RLC series circuit. So that can be done by the use of right hand rule, as in the first year class we had done it. So now we can have the net voltage of VL and VC. Let us suppose we can take it VL minus VC. It is the net voltage of these two vectors and VR is in its own place. So this is the net voltage VL minus VC. Again, from head to tail rule, we can take this vector VL minus VC from tail of the VR and we can put it right here, and by the use of head to tail rule, we can find the net voltage of VR and VL minus VC. This is the net voltage V. Mathematically, we can find it by Pythagoras. V square is equal to VR square plus VL minus VC whole square. Are taking square root on both sides, V is equal to VR square plus VL minus VC whole square under the root. And as we know that V is equal to IR for resistance, V is equal to IXL for inductor, and V is equal to IXC for capacitor. So putting these values here, we can take this I as common outside of the bracket, as it is common in both the terms, so we can take it out as a common, having the square outside. Now again, in the next step, we can also have the current square and under root out of the whole square root. So the square and square root will be cancelled with each other, and finally we will be having R square plus XL minus XC whole square under the root. V is equal to I into the net resistance of the circuit, or simply we can write V is equal to I into Z, where Z is called the impedance of the circuit. What is impedance? Actually, the total net resistance of the circuit is called impedance. It is denoted by the alphabet Z. So where Z is equal to R square plus XL minus XC whole square under the root. Now, what is XL minus XC? This is the resistance, the net resistance of the inductor and the capacitance, which can simply be denoted in mathematical equations with simply X. And this is the reactance of the circuit. We can also find the power factor by cos of theta is equal to R divided by Z. From the diagram, this is, for example, we can have R and this is Z. For example, R and Z. So we can have cos of the theta R divided by Z. Base divided by what? Hypotenuse. So phase angle can be found by the equation tangent of theta is equal to VL minus VC. VL minus VC divided by VR. We can find the magnitude of this angle, phase angle, with the help of tangent of theta. This is also a previous equation used in class first year also to find the angle in the topic of resultant of the two vectors by the use of components. We have three different results for RLC series circuit. First one, if for example inductive reactance is greater than capacitive reactance, so the circuit will be called inductive circuit. When capacitive reactance is greater from the inductive reactance, so we can call it capacitive circuit. And with both the values of the capacitive inductance and the capacitive reactance and the inductive reactance, if their values are equal, so we can call it the resistive circuit. Thank you. Have a nice day.